Note 1 for solving systems of equations by using graphing. I'm given two equations, two unknowns. So as I look at this first equation, I recognize that it's in slope-intercept form, meaning that I should very quickly be able to pull out a slope. As I look at this equation, the slope is 2/3. It also gives me a nice intercept. The intercept would be the y-intercept. It tells me that I can plug 0 in for x, and I get 8 out for y. So I'm going to graph this line. I look at my graph. I start at the y-intercept, which was 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Once I have that starting point, that nice starting point, I follow the slope of 2/3. It's telling me from here I should go up 2 units, the top number is always up or down, go up 2 units, right 3, up 2, right 3. You notice that I quickly ran out of space on my graph, so I can go the opposite direction. The opposite of up and right is down and left. It should form a continuous line. It should be a straight line. All lines are straight. And so once I have several points on there, I just want to connect the dots. There's my first graph. I go to the second equation. You see my first graph. I go to the second equation. I recognize this is in the form of a standard form equation. So I need to be able to pull the slope out using that technique. That technique specifically is to take 1 over 2, A over B, and change the sign there. Since this is a plus, I'll say 1 over 2 is my slope, but I'll make it negative because of the plus that's between those two terms. So my slope is negative 1/2. Slope is negative 1/2. I need a nice starting point. This equation lends itself to me plugging 0 in for x. As I plug 0 in for x, I solve what remains. I divide both sides by 2. Y would be 1. So I have a nice starting point. Again, I go to my graph. It tells me to start at 0, 1. That was the starting point. And I follow my slope. Down 1, right 2, down 1, right 2, down 1, right 2. I'm noticing that as I plot these points, I'm getting farther and farther away from my original line. I'm looking for a point of intersection, so I clearly have to go the other direction. I'll go up 1, left 2, because that's the opposite of down and right 2. Up, left 2, up, left 2. Look at that, I found a point of intersection. Once I find the point of intersection, I connect the dots. This is one of our 3 types of solutions. We found a single point of intersection. I need to identify that. So I go 1, 2, 3, 4, 5, 6 to the left. That would be a negative 6. And up 1, 2, 3, 4. My ordered pair represents the point of intersection. What's special about that ordered pair? That's the only number that will solve both of these equations at the same time. Example, if you plug those in, negative 6 divided by 3 is negative 2. Negative 2 times 2 is negative 4. Negative 4 plus 8 is 4. That's what I'm getting here. If I plug that in for the second equation, negative 6 plus 2 times 4 would be negative 6 plus 8 equals 2. It's the only point that will solve both of those equations. That's what makes this point of intersection so special, and that's how you answer. What is the point of intersection?